Hey guys, what's up? If you remember last time I was doing a topic from electrochemistry. So right now I'm taking the next topic from the electrochemistry. What so far I've done in electrochemistry was what is galvanic cell, what are cell potential, how cell potential are determined using standard hydrogen electrode, and also what are the Nernst equation. So this video is going to be the next topic, and this is going to be about changing Gibbs energy during a chemical reaction. And in another part, I'll be doing the relationship between cell potential and equilibrium constant. So the next topic is relationship between cell potential, standard cell potential, and equilibrium constant. So that's what the next topic is. But we have to, take some, observation from here. Okay, so shall I start here? See, in any, cell reaction, what happened, if you can understand this reaction, which I hope you do, what we see, the first thing, observation I'm trying to make you go through. Observation is that with the time, zinc is converted into zinc ion, so zinc ion concentration increases. Zn2 plus increases. Right? Observation with time. Okay, what second observation we do? That concentration of cuprous ion decreases. And the third you start observing, this is very important, as the concentration of these ions, zinc ion increases and copper ion decreases, the potential difference of the cell, which is 1.1 volt, that's also start decreasing. So the potential difference also decreases. What final observation is, after a certain time, equilibrium is established. Between Zn2 plus and Cu2 plus. So these are some of the observations you go through. And last one is that the cell potential at equilibrium becomes 0. So this is very important. The cell potential at equilibrium become 0. Why? Because no further reaction are taking place, no further oxidation reduction are taking place, or you can say the rate of oxidation and reduction, they both fall into the equilibrium category. So these are the 5 observations. Let me tell you something. With the passage of time, the 5 observations we understand. First, zinc ion will increase, copper ion will decrease, potential difference start decreasing, and after a certain time, when the equilibrium is established, zinc and copper, they both will come under equilibrium phase. And what final observation is, the potential difference of the cell become 0. Okay, now we come to the the last phase here. We remember we have Nernst equation. That was E cell is equal to E naught cell minus 0.059 upon N and log oxidation concentration divided by reduction concentration. What this concentration represent here? Mole per liter. What this one represent? Again, mole per liter. Right? Okay, so What next is there? I'm just putting the value. So at equilibrium, the cell potential has become 0. So this become 0. This is the, if you remember, for this particular cell, the cell potential is 1.1 volt. 1.1 volt minus 0.059 divided by n going to be 2 here, because I hope you know that there are 2 electrons per mole of oxidation and per mole of reduction being involved. So n is equal to 2 here. And then log, of course we'll be writing, Zn 2 plus divided by Cu 2 plus in terms of their molar concentration. Let's solve it. Take this to left side, so this become minus 1.1 is equal to minus 0.059 divided by 2, and this become log K, because at equilibrium they both are in equilibrium constant, so they become K here. Now finally, what log K is going to be? Log K is going to be like this, minus minus is cancelled here, so this is going to be like 1.1 into 2 divided by 0.059. So I remember this will be coming out to be 37.88. So I remember the solution because it's been so many years I've been doing the same. So what next we can do is like log K is equal to 37.88. Okay, so taking anti-log now, taking anti-log, I hope you do know how log and anti-log are taken. So this become K is equal to anti-log 37.88, which you can solve. I believe you can, because this is something you do know. Now the thing is, this is how K is calculated. But one thing is still not done. What is the general equation we can use for K? Because this was for the zinc and copper cell. But for different cell, this particular value is going to be something else. This will be something else, and this will be something else also. This might remain same. So I will be, taking the general equation for, this particular. So general equation for log K and E naught cell. So what log K is going to be? Log K is equal to, let's take a look here. Log K is going to be like, what you have done here. This is like changing the sign. So this will be like log K equal to cell potential and into n divided by 0.059. So I'm writing E naught cell multiplied by n divided by 0.059. So this is the formula for log K. This is the general equation. So I hope you have understand all these, because this is really, really important. Not for your board exam only, but also for the initial sections of the chapter, because that will give you the confidence how you start, electrochemistry. So within very small, span of time, I will take the example, and it says the cell in which there is a cell where the following reaction take place: 2Fe 3 positive, and it reacts with the iodide ion. The products are 2Fe2 plus and iodine molecule. So I2. And it has a cell potential. It has a cell potential, standard cell potential of 0.236, 0.236 volt at 298 Kelvin. 298 Kelvin. So what we need to find out? We need to find out first standard Gibbs energy. So we need to find out standard Gibbs energy. This is the first question. And what next we have? We have to find out the equilibrium constant. So we have to find out the equilibrium constant. So that's the second question. So let me help you with that. So I hope there is something, you already understand that iron is undergoing Iron is undergoing reduction. This is undergoing reduction. And iodine is undergoing oxidation. So this is undergoing oxidation. Why? Because some of you might have problem with that. Let me tell you something, that oxidation number of iron here is 3 plus, but there iron has only 2 plus. So there is a decrease in oxidation number, which is also called reduction. There the oxidation number of iodine is -1. Now there it is 0. There it is 0. So there it is -1. There it is 0. There it is +2. There it is +3. So that's the reason I mentioned that iron is undergoing reduction while the iodine is undergoing oxidation. So that's going to really very, very important here. Let's find out the solution for that. So the first thing we have to find out, what is delta G? Delta G. And the formula was minus NF E naught cell. Right? Okay, let's first start with N. What you see, there is something you have to understand. First, you have to find out total number of oxidation state here. 2 3 are 6 positive, and there it is 2 2 are 4 positive. So there is 6. So they write there, there are 6 positive, and there it is 4 positive. Now there it is 2 negative, and there it is 0. So what is the difference coming out to be? The difference is coming out to be 2. Right here it's 2, and right here it's 2. So simply N comes out to be 2 here. So -2 into 96500, which is the value of Faraday constant, and we have already cell potential been given 0.236. Let's solve it. Whatever is going to be, that's going to be joule. That's going to be negative. I'm not writing -x joule. So this is the Gibbs energy chain for this particular reaction. Now, in the next part, I will help you to get through the solution of log K, right? So, let's do the next part here. If you remember, we just a moment back had log K equal to, it was E naught cell into N divided by 0.059. So E naught cell, you have already there. So what E naught cell is? 0.236. 236 multiplied by 2, because that is the value of N, and then there is 0.059. Okay, so this is equal to log K here. This is equal to log K. Log K is equal to, I'll be using my mobile phone because I'm not very good at, mathematics. So I'm using to solve it. So there is 0.236 into 2, and that's divided by 0.059. So this coming out to be, sorry, this looks like wrong. So it's 0.236 into 2 equal to this one divided by 0.059. So this comes out to be 8, right? So this has finally come out to be 8 here, right? So finally, taking antilog, so if you take antilog, this become K is equal to antilog 8, right? And there you will solve what is the value of K here, because antilog, I hope you know. In case you don't know, as I said earlier, I'll make a video for that, because that's something coming up in my head, that I should make a video for log and antilog. So this is how actually the equilibrium constant and Gibbs energy chain for a cell reaction calculated. I hope you have understand, and you just have to practice them very well. And this is something really important, something easy also. If there is anything you found it was messy, just let me know, because people can be of different ability. I have my own limitation, but I have my own merit as well. But depends how you feel, you have to respond me. And any response that you gave it to me, I would take it most gladly. So with that, I would say thanks for watching. And one more request here, like most of the YouTuber has to do, is if in case you haven't subscribed, this is your first time, do subscribe, hit the bell icon so that you get notification about everything I try to make based on your requirement. So that's it. Thanks for watching.